Connecting. And we are live on Facebook. Good evening, everyone. My name is Joshua Gilliland, and I'm the marketing chair for the Sea Scout Subcommittee and to the National Sea Scout Support Committee. Bruce Johnson was one of the organizers of tonight's webinar, and Bruce is on vacation. So we wish him safe sailing wherever he is off the East Coast. Our speaker tonight is Steve Zubrick, who is with NOAA, the National Weather Service. And Steve is a Science and Operations Officer, and he's for the Marine Program Coordinator. Steve, I'll let you introduce yourself with some of your background, and it's great to have you this evening.
Well, thank you, Josh, for the wonderful welcome, and I really am looking forward to this talk this evening. I'm at the Weather Forecast Office in Sterling, Virginia. It's one of about 125 offices across the country. You'll be seeing some maps of those later on in the presentation. The Science and Operations Officer, or sometimes what they call the SOO position, that person is essentially responsible for the training and professional development of the forecasters at a field office. So I've been in this position for quite a while. And at our office, we have, as many offices have that have coastal marine forecast responsibility, they have marine program coordinators, and that's what I am. So I think it's great that I'm talking to all of the Sea Scouts out there, whether you're a power person or a sailor person. The key thing is that you want to know about the weather. And that's what we're going to go through. We're going to go through a lot of the products and guidance that we have. I'll show you a little bit of meteorology in there. But just remember that the weather is an awesome thing. It's something to be respected. But it's not something that you need to fear. You just need to be aware of it. And I think once you build up this experience and this wealth of awareness of weather, I think that your activities on the water are just going to become more fun and safer. So with that, and Josh will handle questions online. He'll interrupt me, if somebody has a question. So the outline for the talk is I'm going to kind of gear this to my office, which we call the Baltimore, Washington Weather Forecast Office, part of the National Weather Service. But this could apply across the country, an office in Seattle or in San Francisco, LA, Houston, Miami, just anywhere you are. Talk about some of the routine products that we issue. Talk a little bit, at least on the right coast and the south coast, we'll talk a little bit about hurricane season and preparation, resources for mariners, about weather, and marine weather and boating safety. So the mission of the National Weather Service, it's to provide weather, water, and climate data, forecasts, and warnings for the protection of life and property and enhancement of the national economy. That's essentially what our mission is. But if you boil it down, it really is protect life and property. So when you look at the National Weather Service, it's like, how do we do our mission of protection of life and property? And it's a little bit like an iceberg, what you see and hear, through the media, social media, for example, weather forecasts, how does that all come into play? So here on the top are the things that you're mostly accustomed to seeing weather information, either through the TV, through radio, through the internet, through cell phones. There's something there called NWR, that stands for NOAA Weather Radio. That's a VHF radio that we have all across the country, and it's something where if everything else fails, those will typically work if you have VHF receiving capability. And they make these wonderful NOAA Weather Radio receivers that are very low cost, and you can buy them from various vendors. And of course, there's the entire private weather enterprise. Of course, the National Weather Service is part of the government, the federal government. We're actually under the Department of Commerce, and then under the National Oceanic and Atmospheric Administration, which is NOAA. And then under NOAA is the National Weather Service, and that's kind of the pecking order where we're at. So what is all this stuff underneath the iceberg that's beneath the water? Well, if you go deep, deep down, it's observations, plain and simple. And those observations come from a host of sources. There's radar networks, there's satellites above the earth. We launch weather balloons. There's people on the ground taking observations. There's systems that automatically observe surface conditions and report those. If you've ever flown in a commercial aircraft, maybe going from, anywhere, from say LA to Denver or from Miami to New York, a lot of those aircraft are equipped with essentially weather sensor and transmitters that essentially are relaying weather information in real time to central downlinks, and then all of that data is getting into the system. We have lightning networks, both terrestrial based and also from satellite. There's our geostationary Earth orbiting satellites that goes 16 and 17. 17 does the west, 16 does the east. They have a sophisticated camera system. It's the geostationary lightning mapper system. And it essentially is a big sophisticated camera that's looking down on the earth, and it actually can see lightning. And the cool thing about that is you get coverage over the entire globe, and you get the data like it updates every few seconds. So it's very impressive. Data buoys, for those on the water, that's very important. For rivers, we have stream gauges. We have a ton of volunteers that provide us weather information. We have a cooperative weather network across this country where people, every day give us weather observations of like temperature and precipitation, things like that. And we have thousands upon thousands of storm spotters who we've trained over the years and who can contact us. And what that all means is that those observations, they get called into several sources. One is something called NCEP, the National Centers for Environmental Prediction. Those are the folks that are running numerical weather prediction models that attempt to simulate the motions and characteristics of the atmosphere. They do climate and seasonal outlooks. They do forecasts for aviation, for marine. There's a place called the Storm Prediction Center in Norman, Oklahoma. There's the national, it's called the Tropical Weather Center. It's the Tropical Prediction Center, actually, TPC. Some of us old timers know it as the National Hurricane Center. That's down in Coral Gables, Florida. And they certainly are tracking hurricanes in all of the big ocean basins, the Gulf Coast, the Atlantic, the Pacific. And then on the right side here are the weather forecast offices. We essentially bring it down to essentially your level, give you local forecasts and warnings. And we're also aided by the river forecast centers across the country, which provide forecasts of, what are the river levels. And those are certainly extremely important out west, for hydroelectric power generation. Back east, we have a lot of problems with flooding of our main stem rivers, the big rivers. And so, we do that. And that essentially is the National Weather Service. So operations-wise, this U.S. map that you see here, the Weather Service is divided into 6 regions. We have Eastern, Central, Western, and Southern region. And then we also have the Alaska region and the Pacific region, okay? National Weather Service headquarters is located in Silver Spring, Maryland. The National Centers for Environmental Prediction, most of those centers that you see listed here, climate, weather, environmental modeling, and ocean prediction, they're located in College Park, Maryland, near the University of Maryland College Park campus. Tropical Prediction Center down here in Florida. Aviation Weather Center in Kansas, the Storm Prediction Center in Norman, Oklahoma. We also do space weather, believe it or not. You know, when there's solar flares, that's something that we are actually concerned about across the country. They're in Boulder, Colorado. And then the stars that you see here, these are what's called Center Weather Service Units. These are co-located at FAA air route traffic control facilities. They provide information, you know, to the aviation community. River forecast centers are these squares that you see here. There's one like Mid-Atlantic River Forecast Center, or RFC, the Ohio one. You see those scattered across the country. There's essentially 13 of those, 122 weather forecast offices, 21 Center Weather Service aviation units. There is a national aviation center just outside of Washington, D.C. It's a command center. They control all of the air traffic across the country. So, you know, we're essentially, and there's also the tsunami warning centers that we have. We have them out in Hawaii and also in Alaska, certainly. So quite a bit, you know, of weather offices. Here's a map of the local weather forecast offices, and essentially the colors represent, say, the area that office has the responsibility for. So like out in Medford, Oregon, they have responsibility for this part of Southern Oregon, and then they also include part of Northern California. They also include the coastal sections here, so they'll be putting out marine forecasts as well. You go down to like Houston, that's their area of responsibility. Here in the nation's capital, we're the Sterling office because we're located in Sterling, Virginia. And that's our area. And I'll kind of zoom in just to show you, for example, what our area of responsibility looks like. And that is essentially, these are county outlines that you see here. And we essentially forecast for the Maryland portion of the Chesapeake Bay and also for the lower tidal Potomac. Those are the list of counties that we have. We actually forecast in 3 states plus the District of Columbia. Our region is prone to all weather hazards, probably with the exception of volcanic ash. We serve about 27,000 square miles, and we have over 10 million people in this one area. Most of them are concentrated in the Washington and Baltimore metro areas. For marine forecasts, and this will change where as you go across the country, all of the offices break down their marine areas into smaller chunks. For us, we break down the Chesapeake Bay here into these larger sections. Essentially, we have 3 breakouts for the tidal Potomac here, which is a fairly large body of water. And then the Chesapeake Bay is one of the largest inland estuaries in the country. And we've broken that into 11 zones. Our office overview. This is a picture of our office. I'm actually sitting right here in this chair, but we run 24/7, 365 with at least 2 forecasters on duty at any one time. And that's a picture of what our office looks like. Excuse me. So let's look at the routine products that we issue. And this is, again, this will apply across the country. So the main forecast for mariners is the coastal waters forecast. It consists of these elements that you see here: a synopsis, which is essentially a fairly short, concise reading of what the weather is. It's just like if I was in an elevator with you and I would say, well, there's a cold front coming down this afternoon, and winds out ahead of that front are going to be from the south, and then they're going to shift over to the northwest. High pressure will build in tomorrow, and we should have fair weather for the next several days. So it's it'll be something like that. Then one of the mainstays of weather service products are headlines, and by headlines we mean, well, there's a small craft advisory. or there's a gale warning, or there's a storm warning. And those all have different meanings, certainly. We also provide you the wind from 8 compass points in knots, waves in feet, wave heights, and then give you some idea of what the weather's going to be. Thunderstorms, rain, snow, fog, and if you have fog, is there some significant visibility reduction? And here's an example of the coastal waters forecast. There's a link there. By the way, you can go to weather.gov, and that link will take you to our national map, and the map is clickable, and you just click anywhere you want. So like if you want to go out to the Medford office, you just click over, Medford or Oregon, and you would get essentially their page, and then in their page, they would have a marine forecast section. That's how you call that up. And that's typically you see this 3-letter ID. Each office has a 3-letter ID. Ours is LWX, Lima Whiskey X-ray. So the synopsis is right here. It talks about a potent cold front will cross the waters this afternoon in the early evening. High pressure will build overhead for Wednesday. You kind of get the idea there. Then you have a section, and this is only there if there actually are headlines, and that's the advisory and warnings. In this case, we have a gale warning in effect, and also a small craft advisory that essentially follows that gale warning. So the winds essentially are, blowing pretty hard now, but they're expected to die off. And then you have the forecast. And we do a period by period forecast where the periods are essentially 12 hours long. The first period could be a little shorter. So like here in this case, it says rest of this afternoon. And then it goes to tonight, and then Wednesday, and then Wednesday night. And typically those periods run from, say, 6 a.m. to 6 p.m. and 6 p.m. to 6 a.m., so on and so forth. So, marine advisories and warnings. Within the first 3 forecast periods, which are 12 hours, which are essentially the first 36 hours or so, small craft advisories, sustained winds or frequent gusts of 18 to 33 knots. Now, some parts of the country, some of these criteria may differ a little bit. And there's also, for example, seas of 4 feet or greater. And I know in some areas out in the West, they have like advisories for rough bar conditions as well. I'm not going to talk about those. Also, the little flags that you see here, there are actually some offices that actually do fly pennants like this. So a gale warning would be these 2 red pennants. That's when you have sustained winds or frequent gusts of 34 to 47 knots, not associated with a tropical cyclone. And a storm warning is when you have sustained winds or frequent gusts of 48 knots to 63 knots. And that's, again, for our area, the tidal Potomac and the Chesapeake Bay. And all of like the coastal waters forecast, you can get this on the internet, you can get it on your phone. When we have these headlines out, which we're trying to, headlines are trying to kind of raise awareness up a bit, notch it up. We issue a marine weather message, and it essentially has the 4 W's, the what, the where, the when, and the impacts. I guess the 3 W's in the I is what I meant. So this is issued for the first 3 forecast periods. It will highlight the coastal water forecast, the CWF synopsis, will include mention of any headlines that are occurring beyond, say, those first 3 periods. So if we think that there may be a gale warning needed, 48 to 60 hours from now, then, that synopsis part of the coastal waters forecast will talk about that. And this product plays on the NOAA weather radio, the NWR, which is on VHF. And I think some of the Coast Guard sites actually replay this as well. Many sites have what we call convective hazards. And convection means thunderstorms or extremely heavy rain showers. Sometimes you can have very heavy showers without lightning, but it's usually meant to be thunderstorms. The Storm Prediction Center, SPC, we love abbreviations in the Weather Service. They issue what's called convective outlooks. They're issued 4 times a day for day 1. For days 2 and 3, they're issued twice a day. And in fact, there's even convective outlooks that extend beyond day 3 that go from day 4 through 8 that are issued by the Storm Prediction Center. The other thing that a lot of you may know, especially if you're, along the Rockies and east, are severe local storm watches, like severe thunderstorm watches and tornado watches. Those also come from the SPC. And this is an example for our area here in the Mid-Atlantic region of a Storm Prediction Center severe weather outlook. I believe this is the day 1 outlook. And they use certain color codings here, and I'll explain those, what they are. But essentially, as the colors get warmer, the threat gets essentially a better chance of having it. And this might be a graphic that we tweet, on our web page. And many offices will do something similar. So understanding severe thunderstorm risk categories from the Storm Prediction Center, they're shown on this slide here. You go from basically there's no threat of convective thunderstorms to a marginal risk. And in this phraseology that you see here, that's essentially like isolated severe thunderstorms possible for marginal, scattered severe thunderstorms are possible for slight risk, numerous severe thunderstorms for enhanced. We're kind of ratcheting up as you see here. As you go to red, the moderate, widespread severe storms likely, and you might even have some intense tornadoes. And there's the high risk, which most times you don't see those except maybe in the south in the springtime, or maybe the Central Plains. Long-lived, widespread, and particularly intense tornadoes potentially are possible. As a little weather trivia, there's something called a derecho, D-E-R-E-C-H-O, is how you spell it. This is a long-lived line of thunderstorms that can track over 400 kilometers in length, and it's producing, fairly intense wind damage along its entire path. So think of it like thunderstorms forming near Chicago during, say, the late morning, and they're going to race across the west, moving to the east, and hit DC maybe 12 hours later at 10, 11 o'clock at night. And it's just like a bulldozer. It's just generating just tremendous amounts of wind damage. There can be embedded tornadoes, but actually you can get more damage from a derecho than a weak EF0 tornado, turns out. And I used EF0. The tornadoes are rated by the Weather Service personnel after the tornado has actually occurred and after we've gone out and sent people to survey the damage. And there's a scale called the Fujita scale of tornado damage in honor of Dr. Theodore Fujita, who worked at the University of Chicago. He came up with the scale decades ago. We've enhanced it with what we call the E part of it. So it's now the EF scale of tornado damage, and it's a number between 0 and 5. So 0 would be, fairly minor damage. It's probably not going to kill you, but and then an EF5 would be it's going to wipe the ground, everything on the ground, just clean. It's tremendously high winds. For mariners, there's something called a special marine warning, and you should be aware of this. It's issued for potentially hazardous overwater weather conditions of a short duration, and by short, we define it to be 2 hours or less. And it's capable of producing wind speeds either sustained or gust of 34 knots or greater. And it's not something that's covered by, say, an existing longer fuse product, like a gale warning, which would be something that a gale warning would be set up and say, well, it's going to be gale conditions from, say, 10 a.m. until 6 p.m. So that's, an 8-hour period. Gusty showers and thunderstorms with winds greater than 34 knots are certainly a hazard. And why 34 knots? Because it was there was some early research that suggested that 34 knots are essentially something that can toss a boat, can flip it over, a small boat especially. Special marine warnings are issued for waterspouts. I'll show you some example of those. That's essentially a tornado over water. We call it a waterspout. Or hail 3/4 inch diameter or greater. And also we have a situation out here where we may have a gale warning in effect, but we may have a sudden onset of these special marine winds from an approaching gust front or cold front. So we issue what's called a sudden onset special marine warning. And this is what one of them looks like. From a text perspective, it'll have attribution up near the top of it, which office is issuing it, and then it'll say it's a special marine warning for, and then it'll give you the areas that are essentially predetermined. Chesapeake Bay from Pools Island, Sandy Points, Chesapeake Bay north of Pools Island, and the Patapsco River in this example. Here's the radar image here, a little hard to see, but Baltimore is down in here, and here's the Chesapeake Bay, and so this line is moving to the east-southeast, and talks about when is the time that this warning is in effect. It talks about some geographic information on where it is, and it talks about the hazards, the source, like radar indicated or observed from surface stations, and the impacts. And we generate these using like a polygon. So we'll actually draw like a box over this area in here. I don't know why I don't see the box on this one though. Okay, moving on, hurricane season. Josh, are there any questions so far? He's muted.
Not yet, but the night is young.
Okay, perfect. Going to talk about hurricane season and preparation. You can go to Hurricanes.gov. That's a very, very useful website. So essentially, for those, along the Gulf and along the Eastern Seaboard, we're talking about the tropical watches and warnings that are issued by the National Hurricane Center. Now we coordinate with them on that, but in essence, the National Hurricane Center, Coral Gables, they're going to say, there's a tropical storm watch from this point to this point, and there's a hurricane watch from this point to this point. So they govern all of that. They have essentially the final say. A tropical storm is a system of a tropical nature. And by a tropical nature, I mean that it's a low pressure system where the temperatures in the core of it are actually very warm. They originate over essentially the tropical waters of the Atlantic, the Gulf, or the Caribbean, or the Eastern Pacific. Sustained winds 34 to 63 knots is a tropical storm, or 39 to 73 miles per hour. Once you hit 64 knots or 74 miles per hour, sustained, that is considered a hurricane. And then as you ramp up the speeds on a hurricane, there's various categories of hurricanes. So the hazards associated with tropical cyclones are many. There's certainly the wind factor. There's also the intense waves. And along the coast, you have the rip currents that are deadly. You have tornadoes and waterspouts. Also, is the lower two, especially east and south, are tremendously important. Is the storm surge and the inland flooding. So even a tropical storm, if it's moving towards the coast and it has the right combination of winds and water and tides, it can really do a lot of damage due to inland flooding. In the mid-Atlantic states, some of our more infamous storms have been Hurricane Isabel that hit in 2003. Just did a lot of damage around. And then up in New York area, New Jersey, was Hurricane Sandy. Just tremendous damage, especially from the water. These are the scales. I won't go into the scales of hurricane categories. When you have category 1 and 2, you think, oh, those aren't too bad. Well, we're still talking, anywhere from 74 to 110 miles per hour if you happen to be in that core track. Those are tremendous winds. Those are going to do some damage. And then when you get up to 111 miles per hour, or 96 knots sustained, that is category 3. That's considered major, and the 3, 4, and 5 are all considered major. But certainly the 4s and the 5s are catastrophic. Looking at the hurricane season for the Atlantic, it runs June 1st through November 30th. I actually believe that we started this year's season a few weeks early, if I recall correctly. But typically it peaks around the September 10th, and typically goes down. But anywhere in here, like Hurricane Agnes back in 1972, major hurricane that hit the Gulf Coast, and then it came in and just really rained on the mid-Atlantic states. Hurricane Camille, just tremendous devastation along the Gulf Coast. Sandy in 2012. And just recently, in the last couple of years, we've had devastating hurricanes like Laura last year in Louisiana, and then again this year we had Ida that went through there. And then Ida, the remnants of it, dumped all of the rain up in Pennsylvania, New Jersey, New York. They had more deaths up there than they did down along the Gulf Coast, and those deaths were all due to drowning and flooding. You've probably seen this on the news. There's this cone, this track error cone for a hurricane, and it is the probable track of the center of the circulation, but it doesn't mean that that's where the worst conditions will necessarily be. So we always tell folks, don't focus on the track of the storm. And then this cone here is essentially, it's updated every year, the width of it. So as you go out, maybe 48 hours or 72 hours, it essentially widens based on our experience with what we've had over the last several years, what our mean error is in forecast track. So the cone has gotten a little bit narrower with time as our capabilities to observe hurricanes and also to model them have improved. But this is essentially a map that you'll see and that you have to pay attention to. A boat certainly is no place to be in a hurricane. It'll just breaks my heart to see all these boats all smashed up. I think this was down in Key West that the guy that helped put this presentation together, Brandon Fling, he actually did it, and I actually have a place on the water in Cambridge, Maryland, and that's I have the exact same. I have a boat lift, and I have that same little box right there, and I know how much it cost, and just looking at all this damage, just millions and millions of dollars of damage that these hurricanes deal with. So preparedness, there is Weather Ready Nation. You go to weather.gov/ and then WRN. And WRN stands for Weather Ready Nation. And what we're trying to do in the Weather Service over the last several years is we're trying to get people to be weather, aware and weather ready, to be a nation who's prepared for these type of weather, calamities. And so Hurricane-Preparedness, that's a link site up there that you can go to. They've got it in Spanish, talks everything about preparedness for hurricanes, if you live in that area. And most of the local offices along the coast, especially the Gulf Coast and the East Coast of the US, will have a tropical page to highlight things. We certainly have one, weather.gov/LWX/tropical. And that's essentially it for hurricane. Resources for marine weather. How do we convey our message today about marine hazards? We have several vehicles. We have NOAA Weather Radio, which is, again, that VHF system. It has a tone alert capability. So if you have one of these NOAA Weather Radios VHF receivers, they're fairly low cost. You can get them for under, probably $50. We issue a special marine warning, and you've got this box configured for where you're at. It will tone alert that. Certainly websites, the internet, tremendous resource. Weather.gov is the big one here. For us, it's weather.gov/Baltimore or weather.gov/Washington. You get that colorful map that I showed earlier. We have a recorded phone system, and I just realized that this phone number is actually old, so don't try to call it. It'll just give you an intercept operator. But many offices have recorded forecast information. Third parties, U.S. Coast Guard will retransmit, and also the FEMA has an app that will retransmit our warnings. If you're into social media on Twitter, if we issue a special marine warning, it will be auto tweeted, and you'll see a message like this pop up. You can also, check at NWS_BaltWash for, our other information that might be available. And NOAA Weather Radio, just to give you a little bit more background on that, it comes in various flavors. Some of the VHF radios that are multi-frequency, you can dial in different channels and get different, transmitters of NOAA Weather Radio. It's something that a lot of people have on their boats, obviously. You can see that here on the two left pictures. For us, mariners are our top NOAA Weather Radio user group, turns out from surveys. So here on this map, you can see the Chesapeake Bay and the tidal Potomac, and we have great coverage, of those areas. 7 transmitters cover it, that you get the tone alerts, you get the coastal waters forecast, get those marine headline products, and you get observations. This is an example of our website, weather.gov/Washington, for example. This will have the same look and feel if you go anywhere in the country. So it'll, it might say NWS Forecast Office, Medford, Oregon, or something, or Medford, Oregon. So you can click on things. You click forecast, and then you click on marine, it'll actually give you the latest forecast. Most sites have these little icons on if you scroll down on their page, where you can get the marine forecast. And these vary a little bit by office. Our page looks a little different than others, but we usually put in our latest marine discussion from the forecaster. So each office, when we put out a forecast, probably 4 times a day, the meteorologist will sit down and type out a product that essentially describes what the weather's going to be. And we include a marine section in there. Other things that are important for people who are interested in boating in the marine recreation community, and that is tide forecast. So if you live in the tidal area, there's a website, excuse me, where you can go and get essentially what have the tides been before and what are they forecast to be. You can go to water.weather.gov and get that same information. There's also, low water hazards that are also a major impact for folks. Here, when we have low water levels of 1 foot or less, mean low, lower water, we'll issue a marine weather statement. Buoys, these vary across the country. Here in the Chesapeake Bay region, excuse me, we have the Chesapeake Bay Interpretive Buoy System, CBIBS. It was launched in about 10 years or so ago. And there's buoys like you see here. And you can actually dial these buoys and get the latest weather information. All right, on the marine weather and boating safety. And we're coming up on the end of our presentation here. Boating safety. Personal flotation device, wear it. Wear it, wear it. You don't know what's going to happen when you're on a boat. You might get knocked out if a sail boom comes across and hits you in the head and you go overboard. If you got this on, you may have a chance. Could be rogue waves, could be a gust front that comes through. You should always, always wear one and make sure that the people on your boat are wearing them as well. Excuse me. Springtime dangers of cold water, and I would also say fall time dangers of cold water, and even in the winter. Hypothermia occurs when your body's core temperature falls below normal, and it can become fatal. For example, in the springtime, forecasts might say, hey, Saturday it's going to be highs around 80, and it's like April 15th. And you check the water temperature out in the bay, and it's like, 58 degrees. So you go out there, and if you somehow get dunked into the water without any type of, wetsuit on, you could certainly suffer from hypothermia very quickly. So just realize a lot of people have lost their lives from hypothermia going into cold water. Always wear that life jacket. If you have cold water protection gear, great. You can go out and you can enjoy cold water. There's various types of things where you can do that. Wetsuit, immersion suit, dry suit, survival suits. Excuse me. Carry an EPRI with you, an emergency position indicating radio beacon. File a float plan with someone that you trust. If you're going to be back at 4 o'clock and you're not back at 4 o'clock, then maybe someone can go out and look for you or contact those who can look for you. And know the weather before you go out. If the water's too cold, maybe consider staying off the water. Okay, some meteorology. Reading a barometer. Changes in air pressure can be harbingers to weather that's coming ahead. Rising pressure typically indicates fair weather overall. Low or falling pressure can indicate potential inclement weather, maybe cloudy weather, rainy weather, stormy weather. When you're reading a barometer, you look at it straight ahead. If you don't have a digital thermometer, this is an aeronoid barometer that measures atmospheric pressure on the top part there. Be level with the barometer face and read the numbers. And it's really, you can kind of turn this little knob here, and you can set like, well, here's what it was. I'm going to come back and check it in 3 hours, and then if the actual this dial that you set there, if the pressure has gone up, then okay, the pressure is rising. If the pressure goes down, the pressure is falling. How strong is the wind blowing? That's, you know, obviously something that you'd like to know. What is the averaging period for measuring winds? I'm not going to do it here, but I could take a poll and ask people, what do you think it is? Is it over an hour? Is it over 10 minutes? Is it over 2 minutes or 1 minute or 5 seconds? You know, there's certainly the averaging period will impact what you do. So, for example, for the Weather Service, we use 2 minutes to average to come up with our NWS sustained winds, but we use 5 seconds to come up with the NWS gust. And the reason that we do that is because if you average the wind gust over, say, 2 minutes, the wind gust is going to average pretty low. But if you pick a 5-second period for the wind gust, that you're going to get a higher value potentially. Now, it's possible because the gusts, you know, are stochastic and random, and they don't necessarily sample them over a certain period. We will look at over, say, a 10-minute period, and then we'll pick the highest 5-second wind gust. The National Data Buoy Center website, which you see here, www.ndbc.noaa.gov, you can look at all of the buoys information, and you can call up a product that looks like this. This is for TPLM2. This is Thomas Point Light in Maryland. It's in the middle of the Chesapeake Bay. And here the wind speed was sustained 19 knots, and they had a wind gust over a certain period of 5 seconds in the last probably 10 minutes of 21 knots. You can plot those on this website, which is really kind of nice. So the red color is the gust, the blue is the sustained wind speed, the green is the air pressure. And this is over a multi-day period. And so you can see there's times when it gusts up and it, you know, it settles down. Times, GMT, Greenwich Mean Time, also Universal Coordinated Time. It's essentially the time in England at the prime meridian, 0 degrees. In the US, we're in Eastern Daylight Time, so essentially we subtract 4 hours. If you're on the left coast, the Pacific coast, you would subtract another 3 hours. There's the Beaufort Scale of measuring wind. This was, you know, before they, you know, where you just did a visual of what things look like. There's essentially another column in here that would tell you the sea state and, you know, how rough it looks, and you could pretty much estimate the winds, you know, just by looking at the sea state. Not easy. But this thing with the cups and a vane on it and an anemometer, that's the most accurate way that you can measure the winds. But you know, you can actually read the seas here, and you can come up with a little bit of, you know, with the streakiness, and you can essentially tell you how high the winds are if you're an experienced mariner. All right, let's talk a little bit about waterspouts. This is a waterspout off the shore of Crisfield, Maryland on August 19th, 2020. And you can actually see there's a little bit of a ring there. That spray ring here, this is the funnel. This is the parent cloud. This thing is rotating. It's over the water. It has kind of this, you know, clear appearance. You're probably getting 3 knots of wind right around that circular area. And here's another picture of the same waterspout from someone who was actually out on the water. And again, you can see that spray ring. The good thing is that you can essentially see these things pretty far off in most cases. We had some waterspouts on August 13th, 2020. This is at the Patuxent River Naval Air Station, and this was looking out into the Chesapeake Bay. The spray ring again indicates wind speeds 40 knots. Back on September 3rd, we had a tornado that went through Edgewater, Maryland, right along the western shore, just near Annapolis. There was a tornado touchdown here, and then it moved off the coast. And this was a great picture of, in essence, a couple of things. One, you can certainly see the lightning bolt coming out, so that's dangerous. But this cloud feature that you see here, it's kind of wrapping back around. Well, the tornado is essentially back in here, and there's rain that is obscuring it right here. But this is essentially, and this structure right here, this is a shelf cloud. And this is moving essentially, this is not an animation, but this is moving from left to right on the screen. You know, maybe coming a little bit toward this boat here who was out on the water. But essentially the winds are rushing down through here, but also the winds are kind of rushing back into the core of the storm here. And then the tornado, a tornado is essentially a big updraft, and it's essentially sucking everything in. And I've got some other videos here that I'll show you that will show that. And these were just some of the trees, large trees near Edgewater that were uprooted. This is in Hillsmere Shores, Maryland, near Edgewater when that went through. I'll play a couple of these real quick. This was down August 19th in, near Miami, Florida. This is near Sunny Isles Beach on the left here. That's a well-developed waterspout that's moving just along the shore. Here's the same one. And again, that's probably more than 40 knots right there. That's a very very intense funnel waterspout right there. If this moves over land, we give it another name, and that name is called a tornado. This is over the Gulf of Mexico, and there's one, there's two, there's three. I think if you zoom out, I think there were 3 waterspouts that were occurring all at the same time. Just really impressive. And then this is down in Myrtle Beach on 25th to 2020. The gentleman said it quite correct yet. You can see the funnel not really too visible to see. Move it forward, look at all the umbrellas that are getting sucked up in this and are going. You would want to be on the beach here when this is happening. So just very, very impressive storm. We talk about if you're out on the waters and you see something, you can actually call our number here. It's a toll-free number. But since this is a national site, I'm just going to kind of glance through here. Want to learn more about weather? There is something called Jetstream. It's an online school for weather, and you can go to weather.gov/Jetstream, and there's a whole host of topics there that you can learn more information about, you know, like clouds and upper air charts. There's a lot in meteorology that I didn't cover. But anyway, I just want to thank you, Sea Scouts, for bearing with me on this presentation, and that's my contact information there. That's me actually piloting a Chaparral Suncoast 23-footer earlier this month out on near the Chesapeake Bay.
Outstanding. Thank you, Steve. That was very informative, and those water spouts are terrifying. So yeah, not something a West Coast sailor's seen before. So yeah, very, very well done. So we had a couple questions on Facebook that uh, Peter was able to help answer. And just for those who
Okay.
didn't see the chat, and they asked, what's the difference between knots per hour and miles per hour, which goes to the distance factor of 1 knot is approximately 1.15 miles. Can you elaborate that for those who might be unfamiliar with it?
Well, back in the day, the way they actually measured how fast they were moving out at sea is they took some ropes and they tied like a little knot in the rope at various distances, fixed distances on the rope, and then they would dangle the rope in the water, and the faster you went on the boat, the more knots would kind of be exposed, and so that's how they came up with the scale. And then, but it is just a relative scale. It's like you said, it's a different distance. I think a nautical mile is 1.15 miles, versus a mile. And it's just something that mariners typically are more accustomed to, especially those in the older mariner community. It's pretty easy to convert between the two, though.
Absolutely. Well,
I mean, I would go online and Google it, and just
yeah, it's the wonderful tools of Google. So you've been extremely thorough tonight, and no other questions have come in on the Q&A. But if they do, we will forward those on. We appreciate your time and expertise. Weather is mission critical to having a safe voyage. And we appreciate you sharing your knowledge tonight with all of our Sea Scouts who've been able to watch.
Well, I appreciate this opportunity, and I thank you, and I wish you all fair winds and light seas.
Always. Take care, everyone, and stay safe and stay healthy. Take care.